Piles of plastic waste often end up buried underground or dumped in oceans, harming wildlife and the environment. With Earth Day approaching, we're discussing a new way to recycle, turning loads of plastics into useful chemicals and fuels. That's next on this episode of Technology Today. We live with technology, science, engineering, and the results of innovative research every day. Now, let's understand it better. You're listening to the Technology Today podcast presented by Southwest Research Institute. Hello and welcome to Technology Today. I'm Lisa Pena. Earth Day is April 22nd, and this month we're learning about an SwRI program aimed at protecting the planet from loads of plastic waste. Some estimates suggest billions of tons of plastic waste are piled up in landfills and oceans. Our guest today is SwRI chemical engineer Eloy Flores. His team is using a process known as pyrolysis to break down plastic waste and turn it into an oil, recycling it for fuels and other useful chemicals. They're also helping big companies enter a new era in plastics recycling. Thank you for joining us, Eloy.
Well, thank you, Lisa.
So let's start at the beginning. For years, much of the United States plastic waste that wasn't sent to a landfill or recycled was actually shipped out of the country. Where did it go and how was it disposed of?
Well, like you said, Lisa, most of the recycled plastics are actually sent overseas and not handled within the United States. And where they're ending up, unfortunately, is in the oceans due to mismanagement on the end of the end receivers of our recycled plastics. But I guess more importantly, 75% of the U.S. plastics that we put in our recycle bins ends up in landfills. So even if you have a recycle bin at home and you put that on the curb, you can expect most of it will end up in a landfill.
That's disappointing because we put things out on the curb thinking they're going to be recycled in the hopes that we're doing something good. But how do they determine which items go into recycling and which end up in the landfill? Or why do some of our recyclables end up in a landfill?
Well, mostly it comes down to economics and the ability to sort the materials to make the recycling process efficient. And because that technology has not really well, the process of sorting hasn't really gotten to the point where it's very efficient or economical to sort the plastics and recycle them. Most of them do just end up in the landfill. Um, so until there's more advances in that, or technologies that can take mixed plastics or mixed waste plastics, so you avoid the sorting altogether, you take those mixed plastics and then recycle them. Those type of technologies are what is needed to help us avoid either landfilling or shipping our recycled plastics overseas.
What is a mixed plastic?
So mixed plastic is just everything you throw into your recycle bin. All of that material, there's different types of plastics, and each type of plastic, like a bottle or a film that's maybe part of a package you use that you heat up in your microwave, all of those things are different types of plastics. And recycling is very difficult when you have these mixed plastics because they all have different types of properties, and trying to take those different properties and combine them into something that can be recycled is very difficult. So um, this is where, again, a technology that can take mixed plastics, this just stuff almost straight out of your recycle bin, and converting that back into plastics or chemicals or fuels is what is needed.
Okay, so I want to go back to talking about some of our plastics, some of the US's plastic being shipped out of the country. In 2018, that changed. So what happened?
So in 2018, China passed a new policy known as National Sword, and this policy imported or banned the imports of most plastics and other recyclable materials. So now the U.S. had an abundance of waste plastics that they needed to get rid of, and China was no longer accepting them. So then they started sending them to other countries that could handle it, but then those countries quickly became saturated, and mismanagement of those plastic waste made the plastics end up in the oceans. And to just get an idea or to help you visualize how much of these plastics are in the oceans, There's a area of the ocean which is called the Great Pacific Garbage Patch. So this is off the coast of California, and this garbage patch is actually the size or twice the size of Texas. So if you can imagine two Texases floating out in the middle of the Pacific Ocean as waste plastics, that's a pretty significant amount.
That's a depressing image. How did the waste end up in the garbage patch?
So again, it comes down to mismanagement by some of the countries where we've been shipping these waste plastics. They're able to purchase these plastics from the United States at a low cost, and then if they can recycle them, they stand to have to make a profit. However, most of these places they're actually third world countries. They have a difficult time even receiving the material, much less sorting it. And so as a result, they have piles and piles of waste plastics that ultimately just end up either being washed in the ocean or sometimes even worse, they'll burn them as a heat source, which actually it causes other environmental issues with air pollution.
So they were buying our waste plastic in bulk, hoping to make a profit, and that doesn't always work out. So then they get rid of the plastic piles any way they can, and a lot of that ends up in our oceans. So this system obviously is broken. It's not working. In 2018, there was a big change, as you mentioned. These countries were no longer accepting our waste plastic. So at that time, your team had a great solution to handle the overflow of plastic waste. Tell us about what you guys did.
Yeah, so I mean, we've had a long history of working with our clients and doing pilot plant and process development work in with technologies that are in different areas of pyrolysis. So we've done a lot of pyrolysis on things like heavy oil, coal, all type of biomass, and so it was a natural transition for industry and for us to look at what opportunities this pyrolysis process had to convert waste plastics into pyrolysis oils. And these pyrolysis oils, they can then be used as a feedstock for all kinds of different things to produce chemicals or make fuels directly.
So let's talk about pyrolysis. What is it? How do you describe that process?
So pyrolysis is it's a very old technology. In fact, some of the ancient Egyptians used to use it to extract methanol from wood for embalming. So it's been around for a very long time, and basically it uses high temperature and inert atmospheres, so you don't have air or oxygen around. And when you apply high heat in an inert environment, it allows you to break down the organic material into their more basic molecules. Um, so more recently, something known as fast pyrolysis has been kind of the go-to technology for converting biomass into bio-oils. And that's the same type of thing that can be used for plastics. Um, and I think one of the keys for pyrolysis and the plastics and this technology in general is the ability to handle the mixed plastics like we talked about, so that you don't have to have a sorting facility or you don't have to spend a lot of effort upfront sorting the material. And the pyrolysis process is kind of like a garbage can where it can just take all kinds of different materials and convert them into useful products in the end.
How does it convert? Because it a burning process?
Yeah, so again, pyrolysis is traditionally done in an inert environment, so that means there is no air or oxygen around. So we can't. So the air or oxygen is what would cause any type of burning. So it's an oxygen-free environment. So you don't actually burn it. It's just you literally are just heating it to such high temperatures that the molecules are forced to break down into smaller molecules that can be used for other applications.
So as you said, pyrolysis has been used. It's a very old technology, but is the practice of using it for plastics new?
So yes, I mean that's the natural shift that we've seen. Is that many of our clients who had pyrolysis processes are now looking at how they can be adapted for plastics, and it makes a lot of sense. I think it's one of the probably the more robust technologies. There's not a whole lot of commercialized, large scale industrial scale pyrolysis processes out there, but that's something I think that we're going to see in the near future is a lot more of these pyrolysis plants going online.
Okay, so you get a huge pile of plastic, it's mixed plastics. You are able to, are you putting it in a bin or a room, or where do you put it? Can you walk us through the actual process of, starting with a big pile of plastic and then what the end result is and how you get there?
Sure. So typically the pile of plastics would go through some type of pre-treatment process, and in particular here, it would probably be shredded so that you have smaller particles of plastics, and then the smaller particles of plastics would then be fed into what we would call like a pyrolysis reactor. This is not a trivial thing in itself because, again, the mixed plastics have many different types of properties when it comes to things like viscosities and melt points and things like that. But once you get the plastics fed, once you have the shredded plastics, you put them into some type of feeding device, and then you feed them into this pyrolysis reactor. The pyrolysis reactor is going to be high temperature, anywhere from 500, maybe 700 degrees Celsius. And these plastics will then go into this reactor where they'll contact. Typically, we use some kind of heat transfer media, like sand is pretty common. So these plastics will then contact the surfaces of these hot particles, and that's where the pyrolysis will begin to happen, where the material will initially melt, and then there's such a high heat in there that the chemical bonds will then start breaking between these molecules, and you'll start producing smaller molecules, and then as you produce those molecules, they come out out the top of the reactor, and that can be those products can be condensed and used for, like we said, the fuels or chemicals. There's also another byproduct that typically forms in pyrolysis, and that is the heavier molecules will tend to polymerize or form coke particles or carbon particles. And what's interesting about pyrolysis, and in particular using circulating fluidized beds in pyrolysis, is that those coke particles can be circulated to a regenerator, and the regenerator will have air. So the pyrolysis is in an inert environment, the regenerator is an air environment, and the air will burn the coke, which then actually adds energy to the process that can be used again in the pyrolysis portion. So in essence, pyrolysis typically has almost its own fuel source. Uh, it varies depending on the type of material you're feeding. So you may have to supplement the regenerator with other fuel, but at least one of the byproducts of the pyrolysis is something that can be used directly in the process for heat energy.
So the pyrolysis process can kind of, as you said, power itself, which is neat. But the particles that are not used for that are turned into an oil, you've explained to me. Or can you tell us about, what are you actually getting out of the process? Like, what do you see when it's finished?
Sure. So once the plastics turn into their basic components, those components can serve as a building block for many different types of products. The byproduct, I already mentioned the carbon, but some of the liquid products are what may be called gas or pyrolysis gas. This is very similar to like a gasoline or naphtha type material, at least boiling point range wise. But other than that, the heavier components in these pyrolysis oils we call pyrolysis oil, and those can be further fractionated, so you can take pieces of them depending on what particular components or chemicals you're interested in. In some cases, the pyrolysis oils can be used for something known as naphtha crackers. So a naphtha cracker, there's many of them online in the United States and throughout the world, and they are used to crack these lower boiling point hydrocarbons into ethylene and propylene. And then the ethylene and propylene are your basic building blocks for plastics. So that's traditionally how plastics are formed. So you could take the plastics and do the pyrolysis process, then feed some of those pyrolysis oils into a naphtha cracker, which will then take the plastics you started with and convert them back into the basic building blocks used to make plastics, which make the plastics again. So in essence, you're chemically recycling the plastics. Well, not in essence, you are chemically recycling the plastics. And so that kind of makes the whole process cyclic, which is kind of what the world is after right now, or at least industry is kind of looking at. There's a lot of buzzwords around this cyclic plastic processing. And the idea there is you have plastics, you use them, then you reuse them to make more plastics. So the net result is you don't add any new plastics to the environment. So the oils also, there's more you can do with some of the oils. Right now in industry, we're seeing a lot more what we call co-processing, in particular bio oils. Some states that have carbon credits and things like that, they'll use these pyrolysis oils from biomass, and they'll co-process them. So they'll just mix them with conventional feedstocks to refinery unit operations, things like FCC units, and they'll produce gasoline, diesel, and stuff like that. So these plastic pyrolysis oils could be used for that as well. And then there are actually some products of pyrolysis that are very common, things like benzene, toluene, xylene. So some companies are looking at how they can maximize production of those chemicals, which are also used in plastic production, but in other industries as well. So the pyrolysis oil as a whole has a very large slate of chemicals, and many of our clients are looking at ways of trying to produce specific high-value products.
And you are now helping plastics companies implement this recycling process. So, right now, 4 out of 10 of the largest plastics companies in the world are seeking your input. How are you guiding them?
The goal, I think, for most of our clients is to get to a commercialized process. Most of our clients come to us with robust fundamental data that provides like the basis for producing larger scale tests, and or they're trying to take basic processing steps that they've done independently and put them all together into a working process. And that's typically what we do, and we call that kind of the pilot scale, which is where we can produce like half a drum to several drums of a product. And so having done a lot of pyrolysis work, we get to use our team's know-how and experience with things like heavy oil, residuum, and some polymer expertise as well. And we combine all that to help our clients further advance their technology. But as a whole, SwRI has several areas of expertise, from AI and potential plastic sorting technologies, I mentioned our polymer chemists helping us find ways to evaluate the feedstock to a pyrolysis unit, because as we mentioned, the key here is that we're using mixed plastics, so we're avoiding a lot of the upfront sorting steps. But what that means is that you also have a feedstock that is potentially changing, as the different variety of plastics are added and taken away, and that can affect your final product. So trying to understand that is another big area for plastics recycling right now.
Can you define feedstock for us? What does that mean?
So, I mean, feedstock for us, it means anything that well, it's just whatever we're putting into a reactor, I guess, for us. So feedstock could be liquid, could be solid, could be biomass, could be so. So very simple terms, I guess it's just whatever you're feeding into your reactor.
I get it. Okay. The goal of this process is obviously to help the environment, to get rid of all this plastic waste being thrown in oceans, harming wildlife. So, how is this technique benefiting the environment as a whole? What do you see as the big impact here?
So the biggest impact, I think, is to try and remove, a lot of these waste plastics from the process of being either landfilled or shipped to other countries. Uh, so again, with pyrolysis being the most amenable to a varying feedstock of mixed plastics, it's probably the most we could take most of the current surplus of waste plastics that have either nowhere to go or they're going to end up in landfill, and actually turn those back into more plastics or other useful chemicals or fuels. So in the end, again, it's all about reducing the net outflow of waste plastics. so that so we can reduce the environmental concerns that the plastics are causing.
So instead of growing landfills, long term, do you see more of these plastics recycling, these pyrolysis facilities popping up around the country?
Definitely, I think that we'll definitely see, potentially a huge growth in these type of processes throughout the United States, but also in other countries as well. I know we haven't touched on it, but there's some regulatory things that in other countries that are really causing uh, people to or industry to uh, make changes to how they process their plastics.
So these pyrolysis facilities themselves do cause some emissions. Is that concerning or harmful?
Right. So the plastic pyrolysis process, it does need to be industrial scale. So that means it's going to require a lot of energy to break down these plastics into their basic chemicals. And because of that, um, yeah, there's going to be some environmental concerns with emissions and things like that. But there is a recent report that came out by Good Company that did show that pyrolysis technologies for waste plastics would not produce any kind of environmental issues with regard to the current regulated emissions for things that are known as CAP and HAP, which is criteria air pollutants or hazardous air pollutants. So that is very promising because essentially, if you build more of these pyrolysis plants for plastic recycling, and you put conventional environmental controls on these things, there's really no concerns about regulated emissions.
So the benefits to the environment far outweigh any harm that potential emissions could cause. At this point, the emissions are not a concern.
But that's right. I mean, at least based on this first report we've seen from Good Company. But yes,
Okay, so I want to go to a question now. We did talk about a little bit at the beginning, and it as I said, it is disappointing. But many of us already recycle plastics, and we collect them and put them out on the curb. How is your process different, and is it better?
so yeah, so I guess like we mentioned, a lot of the stuff that goes out in your recycle bin is mechanically recycled. That means that it's gone to some type of sorting facility. They've put all the same types of plastics together, and then they clean them, and then they send those plastics somewhere where they just get melted and kind of put back into the plastic products. So this process is better in the sense that it can eliminate the sorting step. There is concern about PVC or polyvinyl chloride, but that's kind of already sorted out in most cases. But so this process can take the mixed plastics, avoid the sorting part, and then not only that, it could be used to make more plastics, is was one option, but then it could also be used to supplement other markets depending on the need. So, if fuel prices somehow became, higher, then it could be more economical to produce fuels from waste plastics. Or certain chemical markets sometimes become in high demand. Certain chemicals become in high demand due to production of something. Um, like, for example, during COVID, we had all these, new PPE materials that needed to be made. So there was a high demand for certain types of plastics and plastic components or chemicals that are used in plastic components. So so that I guess that's like we mentioned, the huge product slate that's produced from this pyrolysis oils. It gives you the opportunity to apply it to all types of different markets and industries. So in whole, I think it's a better solution to the conventional mechanical uh, recycling because it offers so many opportunities in different areas.
Do you eventually see us putting our plastics out on the curbside in our bins on the curb and them going and those bins going to a pyrolysis facility at some point?
For sure, I think there's already companies working on that type of thing, and I think we'll definitely see more and more growth of that, uh, especially with the current administration and the way they're funding things for environmental issues. I think as more and more funding becomes available, then you'll see more municipalities and states and places uh, using pyrolysis as a way of recycling the plastics.
So you mentioned the garbage patch in the Pacific, which sounds just sad and just awful. So when you see pictures or you hear about these oceans being overrun with plastic waste and knowing you are helping to solve this problem now, how does that feel? That's got to be a good feeling.
Um, well, I mean, I would say that we tend to focus on the science and the engineering part of it all. So actually, when I see the oceans with tons of trash and plastic, it kind of makes me feel like we're doing too little, too late. But but that's sometimes how we learn and evolve. So I think we at SwRI, or I at least for sure, come into work every day excited about the opportunities to work on many different things. And I think our passion for what we do here at SwRI really aligns with our clients' objectives and goals. So that really helps us to advance their technologies and not only support their mission, but also SwRI's mission of benefiting humanity.
And what have you enjoyed about this work and developing this technique? I imagine that there are many moments where it is fulfilling, even though you see what you're up against, all this plastic waste in the environment. I'm sure there's got to be moments where it just feels good to be helping.
Sure. I mean, yes. I mean, again, we tend to kind of focus on the science engineering part of it, but yes, knowing that we have some impact on the environment is important. Having done pyrolysis type work for about 15 years now, it's really the enjoyment I think for us comes for, or at least for me, comes from doing the work where we're always pushing the envelope on what's already being done. So even though pyrolysis technology has been around for a long time, the work we're doing is not just your conventional pyrolysis. We're looking at better ways and better operating conditions, or better techniques to to improve the overall process, so we can make it more efficient or make it able to handle the varying feedstocks or produce specific chemicals. So making new discoveries and finding ways to help advance our clients' technology is at least what drives me many of the days to come to work.
What do you consider the most compelling aspect of this technology?
So being able to handle the mixed plastics is very important. I think the sorting step in the current recycling process is what is really slowing things down with regard to being able to recycle more materials. But also, and all that ties into the economics of the whole thing. But Um, so being able to process these mixed plastics, I think, is what will be most compelling. And we've seen examples, in biomass is another good example, because if you have all this biomass material and you have it coming from different parts of the country, and it may be different materials, you may have corn stover, you may have something, switchgrass. And if you combine all these biomasses, or even municipal solid waste type materials, the feedstock is so varying that it's really hard to put it into a process and expect to get the same thing out. And I think that's kind of the challenge right now in pyrolysis, is how do you tune these pyrolysis systems so you can get exactly what you want out. And that's kind of the holy grail of all this, and that's what we're helping our clients and working on every day. So
So, what do you envision for the future of this practice? We've talked about some of the things that could be, but do you see it having a major positive impact on the environment once all the processes are in place and there are several facilities that are going and accomplishing this?
yeah, I think for sure. I think overall the pyrolysis, like I said, will kind of be the go-to process for chemical recycling of plastics. And I think you'll see more and more commercial facilities going online in the future. Um, and I also mentioned, how biomass and coal, there was a coal to liquids boom for a little while, and these things kind of laid the foundation for what we're doing now with plastics and pyrolysis. So there's many different, um, so there's lots of opportunity there.
So, as Earth Day approaches, many of us are thinking about ways that we can help protect the planet. You don't have to be a scientist or engineer to make a difference. So, what is your advice for those of us who just want to make a difference in our day to day lives?
Yeah, I think whether it's unlikely that your recycle bin that you set out every week will actually be recycled or not, I don't think that matters. I think we should just continue to keep practicing, you know, recycling, positive recycling habits, because the future will likely hold solutions to take advantage of those materials. I think we're seeing it also even with the organic waste that we're using. I mean, there's a lot of companies and processes now looking at how to capitalize on those materials. So don't take for granted. Also, I think sometimes people take for granted all the plastics that are around them. I think majority of the items you come in contact with every day have plastics in them. So we're talking about something it's a huge part of our everyday life. And once you understand how much plastics that we use in our everyday life, then I think you can better understand how important it is that we find a way to recycle it or better use it. And I think it's like most things. This is such a huge problem, but every little bit will help. So as a consumer, besides the recycling of making sure you do the recycling, if you can afford it, support products that are also made from recycled plastics. I think that'll help drive everything to eliminate this excess and surplus of waste plastics.
For listeners who have heard your approach today and who like what they're hearing, is there a way for us to contribute to this process now? Is there a way for us to give you our plastics to do something which sounds a little bit more environmentally friendly with? Do you accept plastics right now? Will you
So,
take our plastic waste, Eloy?
so we actually have some pilot plants that we've used, and believe it or not, one of our engineers actually collected a bunch of plastic bottles from people. So everyone brought in their plastic bottles, and we worked. The engineer worked to melt them and try to get them into one of these processes. Um, so we have small scale capabilities right now, so we could probably handle, we couldn't handle everyone's plastics. But I think in the near future, you'll see, you'll definitely see the opportunity where you can contribute your plastics to something like these waste plastic pyrolysis processes.
That would be great. I think that's something we could all feel good about, contributing to this process. And yeah, what you guys are doing is just amazing. The eliminating the sorting process and really opening this gateway for all plastics to be taken through the pyrolysis process, turned into an oil, and from there, becoming useful again. So that so much promise there, and we look forward to hearing about what comes of all this in the future. And just such a great news for the environment. Thank you so much for all you're doing, Eloy, and for taking the time to tell us about it today.
Thank you, Lisa. I appreciate the opportunity.
And that wraps up this episode of Technology Today. You can hear all of our episodes and see photos and complete transcripts at podcast.swri.org. Remember to share our podcast and subscribe on your favorite podcast platform. Want to see what else we're up to? Connect with Southwest Research Institute on Facebook, Instagram, Twitter, LinkedIn, and YouTube. Check out the Technology Today magazine at technologytoday.swri.org. And now is a great time to become an SwRI problem solver. Visit our career page at swri.jobs. Ian McKinney and Brian Ortiz are the podcast audio engineers and editors. I am producer and host Lisa Peña. Thanks for listening.